Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 15, Electromagnetism. Lecture number 24. Lecture number 24. Today topic is electromagnetic induction. So, electromagnetic induction, we already discussed that electromagnetic induction is the process in which induced EMF is produced due to change of flux. The phenomena of the process in which induced EMF is produced in a coil due to change of magnetic flux is called electromagnetic induction. Now, a magnetic field can be used to produce current. For example, if you take this magnetic field as shown in the diagram, this magnetic field, we put a conductor between the north pole and south pole, So, the needle of the galvanometer will show deflection. So, whenever a coil or a conductor is placed between the poles of a magnet, induced EMF or induced current is produced. This process is called electromagnetic induction. When the wire is given movement, is moved across the magnetic field, a small EMF is created. This is called electromagnetic induction. Process is called electromagnetic induction. EMF is called induced EMF, and current is called induced current. Induced EMF increased by moving wire faster. If you give movement to the coil faster, if you give movement faster to the coil, there will be more change of flux, so more EMF will be produced. By using strong magnetic field, the change of flux will be greater. When change of flux is more induced EMF is produced. Increasing the length of wire also cause greater EMF. So, factors affecting the magnitude of the induced EMF: the speed with which the magnetic field is inserted into or withdrawn from the solenoid, velocity, velocity of magnet, velocity of magnet, velocity of magnet, V, or velocity of coil, the strength of magnetic field, B, and the number of turns in the solenoid. So, more will be the number of turns, more will be the change of flux. Change of flux, more will be the induced EMF. Stronger the magnetic field, greater will be the change of flux, greater will be the induced EMF, and also depend on velocity. Simply, you can say that EMF, induced EMF, is directly proportional to VBL, length, magnetic field strength, velocity, and number of coils. Lenz's laws give a way to determine the sign of induced EMF. Lenz's law states that the magnetic field produced by induced current always opposes the change of any change in the magnetic flux, which the induced EMF is directed along the perimeter of the flux surface. The induced current is thus perpendicular to B. Now, this is a coil, and this is the magnetic field lines. So, keep the thumb in the direction of magnetic field lines. The cursed finger will give the direction of electric lines of force. Now, look, students, if you reverse the magnetic field lines, the induced EMF also reverses the direction. So, we will go to another example, Lenz's law. Lenz's law: an induced current always flow in a direction that opposes the change that causes it. In this example, the magnetic field in the downward direction through the loop is increasing, so a current is generated in the loop which produce an upward magnetic field inside the loop to oppose the change. For example, this magnet is given movement in this direction. So the induced EMF will be produced in this direction. When the induced EMF is produced in this direction, here a magnetic field is developed due to the induced EMF, whose north pole is facing the north pole. North pole is facing the north pole, which repel the magnet. Repel the magnet. So if a magnet is given movement towards the coil, if a magnet is given movement towards the coil in this direction, here a magnetic field is created whose north pole is facing the north pole, repel this magnet. So this repulsions opposes, according to Lenz's law, the induced current produce in a direction to produce a magnetic field which opposes the movement of magnetic field towards the coil. If we reverses the direction, in this direction, give movement away to the magnet. When you move away the magnet from the coil, here the induced current reverses the direction. When the current says reverses, it becomes south pole and this becomes north pole. Now the magnet is moving away, so change of flux is due to the movement away of the magnet. So now this magnet will attract to oppose the movement again. The change of flux is due to the movement of magnet away from the coil, so it will oppose this movement which is moving away. So in anything, any whatever the situation is, the induced current will be in a direction to oppose the cause which producing it. If the magnet is given movement away, it will oppose the movement by attracting the magnet. If the magnet is given movement towards the coil, it will oppose the movement towards the coil. So if there whatever the reason is, but it always opposes the cause which producing it. Now mutual induction. In mutual induction, basically based on change of flux, Faraday law. Faraday law states that induced EMF is equal to N del pi divided by del T. You can also write induced EMF is equal to minus N del pi divided by del T. Induced EMF is directly proportional to the change of to the rate of change of flux. Now this is the primary coil and this is the secondary coil. Current is flowing in this coil, due to which change of flux take place in this coil. So current is flowing in one coil and change of flux is taking place in the other coil. So induced EMF is produced in the secondary coil. This is called secondary coil. Secondary coil. This is called primary coil. So if current is flowing in primary coil and induced EMF is produced in the secondary coil, this process is called mutual induction, in which current is produced in one coil. Current is flowing in one coil and induced EMF is produced in the other coil. It's called mutual induction. Now transformer. The voltage of an alternating current can be changed using a device called a transformer. The working principle of transformer is mutual induction. Working principle is what? Working principle is mutual induction. Mutual induction. Working principle is mutual induction. Mutual induction. Now, a transformer contains two coils that are wound around a soft iron core. The alternating current in the primary coil produces an alternating magnetic field. This alternating magnetic field induces an alternating current in the secondary coil. These are called primary coil and this is called secondary coil. Now, here the number of turns is represented by S and here the number of turns is represented by NP. NP is less than NS, so it is called step up transformer. Step up. If if NP if NP is less than NS, step up. If NP is greater than NS, step down. Step down. Step up. Now, transformers are constructed of two coils placed so that charging plugs develop by one link with the other. The coil to which the source is applied is called the primary coil. The coil to which the load is applied is called the secondary coil. The basic operation of transformer are step up, step down, impedance matching, isolation, also called insulation. What is a transformer? Transformer is a device which increase or decrease the amount of voltage. This is called primary coil. This is called secondary coil. The number of turns on secondary coil is represented by Ns, and here the number of turns is represented by Np. Here voltage is Vp and here voltage is Vs. Secondary voltage, primary voltage, primary number of turns, secondary number of turns. Now the ratio between Vs, the primary voltage, and the secondary voltage is equal to number of turns in the secondary coil to the number of turns in the primary coil. It is written already here. Working principle is mutual induction. Mutual induction. Types of transformer. Step up transformer converted low voltage to high voltage. Note that there are more turns on the secondary coil. This is secondary coil. This is primary coil. So for step up, number of primary turn is less than number of secondary turn, and step down, number of primary turn is greater than number of secondary turn. Step down transformer convert high voltage to low voltage. Note that there are less turn. This is number of turns here is greater, so it is called step up. Here the number of turns is greater in the primary coil, so it is called step down transformer. Now, transformer cannot create energy, therefore they must have the same power on each side. Power is equal to IV leads to the following being true of all transformer. This is for an ideal transformer. Ideal transformer. Power at the input is equal to power at the output. IP Vp is equal to Is Vs. Now let's revise, students. Now, magnetic effect of current. Whenever there is flow of current, induced current will. Whenever there is flow of current, magnetic field will be produced. And whenever there is magnetic field, you can produce induced current due to change of magnetic flux. This is the orientation of magnetic field. Magnetic field lines. Magnetic field lines never intersect each other. Magnetic field lines never intersect each other. Where the lines are closer, the field will be stronger. These lines are always tangent to the path. Each line is continuous close curve passing through the magnet. Magnetic field lines. These originate at positive charge and ends on south pole. Magnetic field due to a current carrying straight wire. You can see. You can keep the thumb in the direction up. In the direction of current flow, the curved finger will give you the direction of electric lines of force. Solenoid. Solenoid is what? What is a solenoid? Solenoid is a coil wound round an iron core. Wrap your fingers in the direction of the current and your thumb points in the direction of north pole. Electricity and magnetism. Magnetic effect of this is called solenoid. A solenoid is just a series of loops stretched out as shown in the diagram. With your right hand, grasp the solenoid in such a way that your fingers curls around it in the direction of the current carrying loops. Then your extended thumb points in the direction of the magnetic field. If you curls your finger in the direction of loops or in the direction of current flowing, the thumb will points in the direction of north pole. Magnetic field due to a solenoid is shown in the figure, and right hand rule is used to point the direction of north pole. Right hand rule. The fingers of your right hand wrap around the coil in the direction of conventional current, while your right thumb point in the direction of the north magnetic pole of the coil. Electromagnetic induction. Such a process in which change of magnetic flux take place and induced current is produced. Such process is called electromagnetic induction. Now you can see factors affecting the magnitude of the induced EMF: the velocity, the strength of magnetic field, the number of turns. So I will write VBN. These effect: greater will be the velocity, more will be the change of flux, more will be the induced EMF. Stronger is the magnetic field, more will be the change of flux, more will be the induced EMF. More will be the number of turns, more will be the change of flux, more will be the induced EMF. Lenz's law states that induced current is always produced in a direction which opposes the cause which producing it. So according to Lenz's law, minus n del pi divided by del t. Induced EMF is equal to minus n del pi divided by del t. Mutual induction, in which current is flowing in one coil and induced EMF is produced in the other coil, is called mutual induction. The working principle of transformer is mutual induction. Mutual induction. This is called primary coil. This is called secondary coil. If number of turns in primary coil is less than number of turns in secondary coil, then the transformer is called step-up transformer. This is step-up transformer. In this, iron is used. The coil is wound round an iron core because iron is soft magnetic material. And it is easily magnetized and demagnetized. Now, mutual induction. Transformers are constructed of two coils placed so that charging flux developed by one link the other. The coil to which the source is applied is called primary, and the coil to which load is connected is called secondary coil. And you read the rest. This is the equation the transformer. V is secondary voltage at secondary coil. Vp is voltage at primary coil. Ns is the number of secondary turn, and Np is the number of turns on the primary coil. Types of transformers: step up, step down. Step up increase the amount of voltage, step down decrease the amount of voltage, but the power remains constant. Power at the input will be equal to power at the output. This is for an ideal transformer. Now, after this we will do the numericals. Now, here I will do one numerical for you people, and you will do the other by yourself. A transformer is needed to convert 240 voltage supply into a 12 volt supply. If there are 2000 turns on the primary coil, then find the number of turns in the secondary coil. So input voltage is 240, output voltage is 12. Voltage at the input, primary voltage, is equal to 240 volt. Voltage at secondary coil is 12 volt. Number of turns in the secondary coil. If there are 2000 turns on the primary coil, number of turns in the primary coil is equal to 2000. So use the formula Vs divided by Vp is equal to Ns divided by Np. So I will simplify. Ns is equal to Vs divided by Vp multiplied by Np. Do it. A step-up transformer has a ratio of 1 to 100. Now, step-up transformer, Np divided by Ns is equal to 1 divided by 100. Up 20 volt is connected to the primary coil. What is the secondary voltage? This is Ns and Np, and Vp is equal to 20. So I will write Vs is equal to Ns divided by Np multiplied by Vp. Put the values, you will get the answer. A step down transformer has a ratio of 100 to 1. Step down transformer. A step down transformer, 100 to step down. Number of primary coil is greater than the number of secondary coil. 100 divided by 1. An AC voltage of 170 volt is applied across primary coil. V primary is equal to voltage at primary coil is equal to voltage at primary coil is 170. If the current in the primary coil is IP is equal to 1 milliampere, what is the current in the secondary? Now look students, you will use two equations and you can find the current. Power at the input, IP Vp is equal to Is Vs. With this you can find what is the current in the secondary coil. You can find the current in the secondary coil, and before that you will use Ns divided by Np is equal to Vs divided by Vp. You will get the value of Vs from this equation. So do it as home assignment. These are included in your syllabus, the rest are not included. So if you want to do, you try it by yourself. Thank you students, wish you best of luck. Allah Hafiz.